Hi everyone. In this video, I will be demonstrating Factorial ANOVA using SPSS version 29. And the model that we are testing will contain two independent variables, basically making it a two-way Factorial ANOVA. Other models are possible as well. That include more independent variables. Those, you might have like a three-way Factorial ANOVA or higher. Those are fairly atypical. And most of the time when you see a Factorial ANOVA in the literature, you're going to probably see something along the lines of a two-way Factorial ANOVA. So that's going to be the emphasis in this presentation. Now, before I actually open up SPSS and begin running an analysis, I want to talk just briefly about the model in terms of the statistical model. So right here, I have a diagram where I have basically two independent variables. I'm just calling them IV1, IV2. And you'll notice that we have arrows pointing from those boxes to Y. And then you'll also notice that I have a third variable in this analysis. It's this IV1 times IV2, and that is referred to as the interaction term. So we're talking about this variable right here. So the basic idea from a statistical standpoint with this type of model is that when we are including an interaction term in our model, then we're essentially saying that the effect of IV1 and IV2 on Y is not just, their effects are not just independent as reflected by this box here and this box here, but also that there's some interactive effect or, kind of a joint effect, if you will. And so that effect is above and beyond the independent effects of IV1 and IV2. So there's an effect that's produced by their product, so to speak, that is above and beyond the independent effects of those two variables within our model. So this is just kind of a general overview or a general way of thinking about the statistical model that's being tested. And again, this is for a two-way Factorial ANOVA, where we have IV1, IV2 as our two factor variables. Now, when we specify our model with an interaction, oftentimes this is coming from a conceptual framework that assumes that the effect of one variable on Y is being moderated by or impacted by the second independent variable. So that's kind of the conceptual framework that typically guides the inclusion of a factorial, or excuse me, an interaction term within a statistical model. So to show you kind of what I'm talking about, if we look right here, I'm including in this a couple of conceptual possibilities. So on the left, you'll see that I have a conceptual model where we are stating that the effect of the first independent variable on Y varies across levels of the second independent variable. And so, in other words, that second independent variable might be considered the proposed moderator, and that variable is affecting the relationship that we would see between IV1 and Y. So what that means, when we talk about a relationship in the context of analysis of variance, it's basically being manifested by a difference in means. So we might say, kind of using that way of thinking, that that the interaction might be manifested in terms of the differences in means between groups on the first IV variable might differ themselves across levels of the second independent variable or the proposed moderator. So that's one conceptual possibility. Another conceptual possibility might be that the effect of IV2 on Y is being moderated by the first IV. Okay, so in other words, the mean differences that we might see between groups on the second independent variable might differ across levels of the first independent variable. And so so as we're thinking about this, we could think in terms of, kind of a focal independent variable and a proposed moderator variable. So on the left over here, we might say that IV1, this is kind of our focal independent variable. This is kind of the variable that we're mainly interested in, perhaps from a research perspective. And, and with that variable, we're interested in accounting for variation in Y, but we also might think that that the effect of that variable is moderated by, it may be amplified by, or it might be kind of reduced by the proposed moderator. which is IV2 right here. So in other words, we've got a designation from a conceptual standpoint of a focal independent variable or focal antecedent and a proposed moderator for that model. And then for our second possibility, we could treat IV2 as our focal independent variable and IV1 as our proposed moderator right here. So the conceptual possibilities that I'm talking about really comes out of your theoretical framework. So like, for instance, if I was doing an experimental study and I wanted to look at the effects of, an education, two or three, let's say three educational interventions on academic achievement. From a research perspective, I might be interested in testing whether the intervention has an effect on achievement, but I might also have some reason to believe that the effect of the intervention on achievement might vary depending on who is receiving the treatment. It might be that maybe individuals who are high in socioeconomic status, maybe the effect of the intervention on achievement is different between people who are high on socioeconomic status and those who are lower. So that's a possibility right there. So, but that comes from a theoretical framework. By the same token, it might be possible that we're interested in the effect of SES, but then different environmental conditions might moderate the effect of SES on achievement. And so then in that particular case, the environmental interventions or whatever or the environmental conditions might serve as a moderator of socioeconomic status on academic achievement. So the issue of the conceptual framework that you are starting from comes out of your theoretical reasoning and your theoretical framework. But from a statistical standpoint, the interaction, when we test our model out using our Factorial ANOVA, the interaction effect, it's basically a symmetric effect. In other words, it's consistent with either of these possibilities. So in other words, when we test our model out and we find a significant interaction, the interpretation of which variable is having a moderating effect really boils down to your conceptualization of the focal independent variable and the proposed moderator. So that's very important to keep in mind. Now, sometimes, quite frequently, a lot of times folks will just kind of run maybe a Factorial ANOVA because they have two factor variables, IV1, IV2, and they kind of run it through analysis of the SPSS or whatever program, and by default the program will generate that interaction term. And so in that case, maybe they don't necessarily have a conceptualization of a focal independent variable and a proposed moderator. They just are testing whether there's some kind of interaction effect above and beyond the independent effects of IV1 and IV2. So that's another possible approach that one might take when they are running a Factorial ANOVA. They, from one standpoint, you might have a conceptual model that you're testing where you have in mind and kind of a priori a focal antecedent and a proposed moderator. The other is probably a little bit more exploratory in nature, in that you just sort of enter in the IV1, IV2 variables, and then out comes from your analysis an interaction effect that's been tested, and then you can kind of see whether there's some evidence of some interaction effect over and above the independent effects of your IV1 and IV2 variables. So for our demonstration, we're going to be testing whether students receiving one of three instructional methods will differ significantly on academic achievement. And we're going to be testing whether their level of interest in the subject matter moderates any effect of instructional method on achievement. So from this standpoint, the wording that I'm providing right here is reflecting a conceptualization that I have, that I believe that there will be differences on academic achievement as a function of instructional method. But I also have, with my conceptualization, the possibility that your level of interest in the subject matter might serve as a moderator of any effect of instructional method on achievement. So in other words, your level of interest might alter the relationships that we might see between instructional method and achievement. So in our data set, instructional method is a categorical or factor variable that's coded 1 for method A, 2 for method B, 3 for method C. And interest is also a factor variable. Basically, it's ordered categorical because essentially we've got it coded 1 for low interest, 2 for high interest. And then achieve is going to be treated as a continuous dependent variable. So we're going to be testing all of our effects in this demonstration with an alpha set at 0.05. And then assuming a statistically significant interaction, we'll follow up with simple effects tests by using the EM means tab. So I will tell you this, that in older versions of SPSS, for you to carry out simple effects tests, you would have needed to use syntax. In these more recent versions of SPSS, they've now added an option to carry out these tests underneath the EM means tab, and that's the estimated marginal means that it's referring to. So since we have 3 levels of factor A, instructional method, and 2 levels of factor B, then essentially we have a 3x2 factorial ANOVA. So if you see an article or something like that where somebody is saying, well, we ran a 3x2 factorial ANOVA, it's actually referring to the number of factors. The first number is the number of levels for the first factor. The second number is the number of levels for the second factor. And then if you multiply those, that gets you the number of cells within the analysis. The cells are just basically reflecting the crossing of those 2 factors. So at any rate, we're not going to be covering all aspects of factorial ANOVA or assumptions. This is mainly going to be kind of a walkthrough and discussion of this type of analysis. So what we'll do is I'll just show you really quickly some screenshots, and then I'll actually open up SPSS and run the analysis. So to carry out the factorial ANOVA, you'll go to Analyze, General Linear Model, and then click on Univariate. And under there, when this box opens up on the right, you're going to move your dependent variable to the dependent variable box. You'll move your independent variables over to the fixed factors box. And then from there, you've got various options that are available. If you click under the Options tab, you'll want to ask for descriptives, effect size, power, homogeneity tests. These are fairly common things to request. There are some other options as well that might be useful, like the residuals plot and so forth for evaluating assumptions. But we're not going to do that for this particular demonstration. We're just going to leave things fairly simple. So next, if you go under EM means, under that tab, what you'll do is you're going to move all of this over here on the left. We're going to move it over to the right. So you'll be essentially highlighting and clicking the arrow. It's actually going to be facing the opposite direction until you move it, and then all this should be displayed under this box right here. Now, again, as a follow-up to a significant interaction, oftentimes what we want to do is we want to probe that interaction. We want to describe what seems to be going on. And so one way to do that is through the use of simple effects tests. So simple effects tests basically involve testing group differences with respect to the dependent variable using one independent variable at different levels of the other independent variable. Okay, and so the idea, theoretically, what we would expect is that if there is an interaction, we would expect that the differences in means between levels on the first independent variable, those differences would themselves differ across levels of the second independent variable. So that's where the simple effects tests are coming from. So when you click on this little check mark right here, or check right here, then you are essentially invoking that option. You'll notice that down below you've got this little confidence interval adjustment option as well. And so with this, there's a little drop down. So if you click the little arrow, let me see if I can find it here. Once you click the little arrow, there'll be a little drop down, and you've got 3 options. You've got LSD for Fisher's least significant difference. It also says none. Then you've got Bonferroni and Sidak procedure. And so if you just leave it on LSD, then essentially what's going to happen is there's not going to be any type of correction to the p-values and so forth for multiple tests. And keep in mind that when you're carrying out multiple tests, then you run the risk of type 1 error inflation. And so you can end up inadvertently rejecting a null hypothesis in this context with respect to the simple main effects test when in fact maybe you shouldn't. So you have the options of the Bonferroni procedure or Sidak procedure. For this demonstration, I'm selecting Bonferroni for Bonferroni adjustments to be made. So then after that, what we'll do is I'll kind of scroll down a little bit further, and you'll see that there's an option for Tukey's Posthoc test. So if it happens to be that you want to carry out tests of mean differences for your independent variables and without regard to the interaction itself, then this might be one option that you have. You'll notice that in this screen right here, I've moved instructional method over to the right, but I haven't moved interest over to the right. And the reason why is because interest only has 2 levels. So the test in the ANOVA table of the difference in on the mean difference involving the interest variable is going to be essentially the test of the difference between 2 groups. So there's no need to do that. So I've moved the method variable over to the Posthoc test, and I clicked on Tukey for this particular demo. So if you go under plots, you have several options that you can make. So right now what I've done is I've selected, let me just kind of show you here. You'll notice that you have a horizontal axis box and a separate lines box right here. So if I move method over to the horizontal axis and then click on add, which would highlight once that's moved over, then what I'll end up with is a profile plot of the means for instructional method or by instructional method. If I move the interest variable over to that box, then I'll get the same thing for interest, basically a profile plot of the means by interest group. You'll notice that down below, I've also selected, or you'll see that there's method by interest. And so you can use profile plots also to provide some visualization of the nature of an interaction if one, is there. So to do that, all you need to do is you move one variable over to the horizontal axis box. So in this case, I moved method over to the horizontal axis box, and then I moved interest over to the separate lines box right here, and then I clicked on add, and then that's how we get that last term in this little box below. Now you've got a couple of chart type options right here. You've got line chart and bar chart. So you got those 2 options right there, and then you can see that, you can, if you click on bar chart right here, what'll happen is that, you can also get error bars, or if you just want error bars with the line chart, you can click on that and get that. But you can also get kind of confidence interval bars and standard error bars and so forth. Actually, for either of them, I'm sorry. You can get them for either of them if you just click include error bars. So that's just kind of an FYI right there. So at this point, we will go ahead and perform our analysis. So I'm going to open up SPSS and just kind of specify all these, and then we'll generate our output and talk through it. Okay, so here we are. We have our data set opened up. We've got instructional method, interest, and achieve. And I will tell you this, that oftentimes I tend to prefer to include labels for my levels for my factor variables. If you double click under method, your variable, like in this case method, you can go under values and you can set the values associated with the levels of your variable. And so that what will happen is that in your output, instead of getting just 1, 2, or 3 for each level of that variable, you'll see method A, method B, or method C. So anyway, there's that one. And then you can also see too that if I click under this one right here for the interest variable, there's low and high. So again, using those labels, you can get that to show up in the output, and it won't be quite as confusing as just seeing the numbers that represent the levels of that variable. Then we have our achieve variable right here. So we'll go ahead and click on Analyze. We'll go to General Linear Model and Univariate. We'll move Method and Interest over to the Fixed Factors box. We'll move Achieve over to the Dependent Variable box. We'll click on Options, and we can select descriptives, effect size, there's power, there's homogeneity tests. Again, we're just going to kind of keep our options fairly simple for this demonstration. Next, we'll click on the Estimated Marginal Means button right here, and we'll move all of this stuff. I'll highlight and move it over to the right for display means for, and I'll click on simple main effects. And then we have this little drop down I was telling you about. So for this, I'll select Bonferroni. We'll click continue, and then under posthocs, just for the purpose of this demonstration, we'll go ahead and move the method variable over, and then click on Tukey's right there, click on continue. And then under the plots tab, we can make our selection. So I'll move method over to the horizontal axis, click on add. We'll move interest over to the horizontal axis, click on add. We'll move method to the horizontal axis, interest to the separate lines, click add. In terms of chart type for this demo, I'm going to go ahead and select bar chart right here, and I'll click on include error bars. And so you've got two options. You've got confidence interval, 95% confidence interval that will be formed around your means. And then you also have a standard error option as well. So you have either of those options. So I'll click on confidence interval just for this demo here. So we'll click on continue, and now we're ready to go. Now I do want to mention that one thing I've noticed is that in a couple of more recent versions of SPSS, and it seems to be maybe the case in the current version, if I run this analysis and then I wanted to, let's say, rerun it or include different variables and so forth, and then rerun the analysis, some of the options don't hold like you would want, in particular that EM means. So sometimes you might have to go back and reset this if you rerun your analysis. So that's just kind of a heads up on that particular point. So we'll click on OK to take a look at our output. And so you can see that in our output, we've got, first off, at the top, you'll see that we have our table of descriptive statistics. So up here's our descriptive statistics. So you'll see that we've got means and standard deviations and sample sizes for each cell, and then also for each level of each of the factors. So you'll notice that we've got the mean on achieve for low and high method A right here. There's our standard deviations, sample sizes right there. And then this total mean right here is just the mean for folks receiving method A. There's your standard deviation and the total sample size. So that's kind of a general breakdown in terms of the descriptive statistics right there. I'll also kind of point out too that you have down at the bottom in the total area right here, this would be the mean for all individuals who were low in interest without regard to their instructional method. There's a standard deviation sample size. This is for individuals high in interest. There's your standard deviation and sample size right there. So those are just your basic descriptive statistics, basically for each variable without regard to the other variables. So we'll kind of scroll down a little bit more, and we'll look at the Levene's test. And so you can see with Levene's test right here, basically this is a test of the assumption of homogeneity of variances. So in the context of a one-way analysis of variance, you're essentially testing for equal variances on the dependent variable across your groups. Okay, so the assumption, one of the main assumptions of analysis of variance is equal variances, and so if that assumption is not met, then that can produce situations where you end up with an inflation in type 1 or type 2 error. So in the context of our factorial ANOVA, you're essentially testing, you're still testing for equal variances, but essentially you have in our case, we have 6 cells in our data set. And so you're essentially testing for equality of error variances across those cells. So that's kind of the way to think about it. So you'll notice that we have basically 4 types of Levene's tests that are printed out. So in older versions of SPSS, there was just the first test, which is this one right up here. The other tests are essentially kind of more robust tests that, if you happen to have a situation where you have concerns about your Levene's test being affected by non-normality on your dependent variable, then you might look at some of those other options. But we're going to just stick with the default, kind of the historical version of Levene's test for this demonstration. So you'll see that we have this p-value right here of 0.132. And so the null hypothesis is equality of variances. So if our p-value is greater than the alpha level that you set, conventionally it's going to be 0.05, then in that particular case, then we're going to be maintaining the null, which is to say, assuming equal variances. If we end up rejecting the null in this case, then we're essentially saying that we have unequal variances. And so that would reflect a violation of that particular assumption. So for our demonstration right here, we would, given the p-value of 0.132, that would lead us to conclude that we have met that particular assumption, or we have some reason to believe that we've met that assumption. I will say there are other ways of assessing that particular assumption, not just using Levene's test. With Levene's test, the power of that test is affected by the same things that affect power of other tests, which is to say that one of the big factors is sample size. So if you happen to have a really large sample size, it is possible for there to be a rejection of the null with Levene's test, even if the discrepancy between error variances is very small. So that's why other measures might also be something that you look into. So we'll scroll down a little bit further, and you see that we have our analysis of variance table. And so it's just this table with tests of between subjects effects. So we have a breakdown in terms of our 3 effects that we're testing. If you remember that diagram I had earlier on of the statistical model, we had the effect of each independent variable, the independent effect of each of those variables, and the interaction between method and interest. So right here, this is for method, we have our F test for that. So you'll see that we've got our there's our degrees of freedom between for that variable right there. There's the mean square. Here's our sum of squares, by the way. So if we just take sum of squares divided by degrees of freedom, that's going to get you your mean square. And if you divide that mean square by the mean square error, that's going to get you this F value right here. And we have our significance levels. So that's the p-value, which is testing the main effect of instructional method. So when we talk about the main effect of instructional method, we're talking about its effect across levels of interest, or across levels of the interest variable. So we're essentially looking at differences in instructional method, essentially controlling for the other variables in our model. And so we're essentially kind of taking care of that. So now we find that we have statistical significance there. So the main effect of instructional method is significant. So that would tell us then that we have an apparent effect of instructional method. You can see that we have this partial eta squared value that's given right here, which can be used to judge the effect size. So a conventional, if we want to use some conventional thresholds for evaluating eta squared and partial eta squared, we might use Cohen's conventions of 0.01 for small, 0.06 for medium, 0.14 for large. Okay, so using that, then we would say then that clearly we have a large main effect for instructional method. Then for our interest variable right here, we have an F test, and you can see that there's our F value. It's very small, and we can also see that it's not statistically significant. So we do not have a significant main effect for level of interest in the subject matter. And as we look at the partial eta squared right here, it says 0.021. So you can see that that's reflecting basically a very small main effect for student interest. Then finally, we have our interaction effect. We've got method by interest, and you'll see that we've got there's our F value, there's our P value that's given. And let me kind of clean this up just a bit so that we can highlight this. So we have a significant interaction effect, and we also have a large effect size. So what this is basically telling us then is that there's an effect of the interaction between instructional method and interest above and beyond the effects of are the independent effects of method and interest basically by themselves. So we have evidence of a statistical interaction at this point. Now, the next step in all this is to kind of, we would want to look at kind of probing that interaction to get a flavor of what's going on. And then also the sort of the angle by which we look at that interaction is kind of unpack it depends also partially on how we think about, which variable might be the independent variable and which variable might be the proposed moderator. So those are, again, you have to kind of think in terms of the statistical interaction here, because it's significant. That's consistent with both possibilities of one possibility where instructional method, the effect of instructional method on achievement is moderated by interest. The other possibility is that the effect of interest on achievement is moderated by method. So how we kind of go about probing and interaction and interpreting the nature of the interaction depends partially on that conceptual framework. Obviously, if we just had come into this situation without any conceptualization about a focal independent variable and moderator, then we could just kind of probe through the output and maybe describe it in however way that maybe makes sense to us. But we'll go ahead and scroll down, and you'll see that in the next part of our output, we've got the grand marginal mean right here, and then we've got the marginal means for instructional method. Now, when it comes to actually, our test of involving the analysis of variance above, what we're basically doing is we're testing these marginal means. Okay, so the marginal means, when it comes to actually, discussing the means and which means are being compared, we aren't making comparisons involving the means that we saw in that descriptive statistics table above. Rather, we're using these means right here, which are essentially kind of capturing adjustments for differences in sample size. Now, if it was the case that our cell means all had equal sample sizes, then the means that would appear down here under estimated marginal means would be the same as they appear in the table of descriptive statistics. But in our case, because our cell sizes differ, then the computation of these means right here differ from, in certain ways from the means that you see in the table of descriptive statistics. And I'm not going to unpack all the math behind it, but when it comes to the actual comparisons that we are talking about that's described in that ANOVA table, it's involving tests of these marginal means. So when it comes to reporting, you're going to want to make sure that you report on the marginal means and not just simply rely on reporting on the mean standard deviation in that original table. You can report on them, but you also want to make sure that you are reporting on the marginal means, because those are essentially what are being tested with our ANOVA. So with that said, you can see right here that in terms of the marginal means for method A, method B, method C right here, it's 3.8, 7.042, and 6 right there. And just to reiterate that point that I was talking about, let me just kind of come over here and I'll write those values out. It was 3.8, 7.042. Terribly written, of course. I'll put a little 7 here with a little dash just to reiterate that, and then 6 right here. So if I go back and we'll just kind of scroll up and compare against what we had in this table above, you'll see that the mean for method A, there's the 3.8 right there. In terms of method B, we have a 7 instead of the 7.02, which was the marginal mean right there. And then you can see for method C, it happens to be a 6 right there. So there's a little bit of a difference, mainly with respect to that second group, basically method B. The same would be the case with respect to the interest variable right there. If you look at the means in this table right here, you've got 6.51 5.6154 for the low. And then if we scroll down and we look at the means right here, you can see there's a difference. You can see right there for the low, we have 5.844. So that's a difference between those values. And so that's just kind of highlighting the difference. Again, I'm not going to get into the math behind it. I just wanted to kind of highlight that difference and really emphasize that when you're reporting, you want to make sure that you report on these marginal means. These are basically means that are adjusted for the other variables that are included in the model. So we'll scroll down a little bit further. You can see that we also have a table containing means, basically our cell means. So these values will be the same as those in the table of descriptive statistics. Now, we'll scroll down a little bit further, and you can see that in this section, it says method by interest, okay? So method by interest. So in terms of this breakdown right here, you'll see that we've got these pairwise comparisons. So these are simple effects tests that I was telling you about. So in this case right here, we've got, you'll notice that we've got method by interest. So we're basically, what it's saying is we're going to compare students in these different instructional methods groups at different levels of interest. Okay, so you'll notice that we've got over here, a designation of low interest and high interest, and then over in this section over here, the remainder of the table, you'll see that we have comparisons between method A, method B, method A versus C. We've got B versus A, B versus C, and C versus A, C versus B in both of those groups. And you'll notice that within each of the interest groups, some of those comparisons repeat. So there's not a need to be redundant in terms of how you're reporting on your data here, or your analysis here. So let's just say that we've got method A versus method B. You'll see it says there's an I column and a J column right here. So I is referring to essentially the first group. Will be computing the mean for the first group. The mean for in the low interest group, the mean for method A is 2.6 right here. For method B in the low interest group, it's 7.333. So if I take the 2.6 and subtract the 7.33, then we get this mean difference right here. It's just basically I minus J of negative 4.733. Now, the question is this a significant difference? And you can see that we've got our little p-value right here, and so we would say that that difference is significant. Also, pay attention to the direction of the difference. If I minus J, if that number is positive, that's telling us then that the group labeled I has the higher mean. So in this case, because this value is negative, it actually is telling us that students who were low in interest and in method B, that those students had a greater level of achievement than those students who were lower in interest and in method A. Then we can look at method A versus C. So now method A versus C, we've got our mean difference right here. So in this case right here, I'll kind of get rid of that right there. In this case, we can say that, again, we have the mean for low interest method A versus low interest method C. So it's 2.6 minus 7.6. That gets us the difference of -5 right here. So again, that's method A minus method B, and so that's telling us our method C, and that tells us then that students in method C had a higher level of achievement than those in method A. And so you can see that the difference right there is also statistically significant. Then we've got a comparison between method B and method C right here. So in this case, we'll just kind of clean that up just a bit. And actually, we'll go ahead and clean up everything right there. So now we have low interest method B minus low interest method C right here. And so now you can see in this particular case, we still have a negative value, but that difference is not statistically significant. So we have actually differences between method A and B and method A and C in the low interest group. Now, if we look in the high interest group, then we've got method A minus method B right here. We have a negative value. So again, method B students the mean is higher than method A. So we still have a difference here, but it's not significant. So you can see right there that there's a difference between method A and B for those students who have low versus high interest. There's a difference in the outcome. Previously, in the low group, we had a significant difference between students in methods A and B. And among the students who were high in interest, there was no difference between the students in methods A and B. Then if we look at the difference between method A and C, then in that particular case right here, we have a small positive difference right there. And we also find that that's not significant. So again, we have a difference between method A and C between groups who are different in interest levels. So students who are low in interest, there was a significant difference between students in methods A and C. Among the high interest students, there was no difference. So then if we look at method B versus C right here, we see that there's our difference. It's a positive difference. And you can see that that's not significant, which is actually consistent with what we saw with the low interest group there. But because some of these results are different depending on whether our students were low versus high in interest, that's consistent with what we would expect if there's some type of interaction that's going on, because the mean differences among the instructional method groups is varying across levels of the interest variable. So at this point, we'll kind of scroll down a little bit further. And you'll notice that there's univariate tests that are printed out right here. If you wanted to report on kind of an omnibus effect of instructional method for students who are low and students who are high, you could certainly do that using these tests right here. So you'll notice that we have the low interest students right here. This F test right here is just a test of differences for students who are in those different instructional groups. And so this is just basically saying that there are significant differences for students in these different instructional methods for those students who are also low in interest. Among those students who are high in interest, we see that there are no differences in terms of the effects of instructional method on achievement. Now, if we scroll down a little bit further, you can see that we've got a different kind of set of output here. We've got method by interest. So it's kind of a reversal, if you will, of what we were just doing. Now, remember that we started out this discussion by assuming that interest would serve as a moderator of the effect of instructional method. But if I had come at this from a different angle and assumed that the effect of the proposed moderator would be instructional method, then in that particular case, I'd probably be focusing my attention on this output right here. So you'll see in terms of the estimates right here, we have the same means that we had before. We had the same cell means, but now in terms of the pairwise comparisons, you'll notice that this column right here, these are levels of that proposed moderator, which in this case might be instructional method. And then we just have pairwise comparisons between students who are low versus high in interest at each level of instructional method. So you'll notice that we have students who are low in interest versus high in interest in method A. So in that case, we have a comparison between these two means right here. We have 2.6 minus 5, and that difference then is negative 2.4, and you can see that there's a significant difference between those two groups. There's no need to look at the next row because it's just a repeat, just kind of a reversal of the direction of the means that are being shown right there. So there's not really any need to go to that next row in method A. When we look in method B right here, we have low versus high. So in this case, we have this comparison between these means. So 7.333 minus 6.75. So the difference right here is small, negative, and also not significant. Okay, so then for the third group, for the third instructional method group, the comparison between students who are high versus low in interest, you can see there's the mean difference. Because that value is positive, that's telling us that students who were low in interest had higher levels of achievement than those who were high in interest. So and that's reflected right here. That wouldn't ordinarily make sense, but this is fictional data, so we'll live with it. So in this case right here, we can see that the difference right there is statistically significant. So at any rate, you can see right there that we've got three sets of results. We have the comparison between low versus high in method A. That effect is significant, or that difference is significant. The same goes for method C, but we have a reversal of the direction of the difference in means between low and high interest students. And then for method B, we also have no significant difference between students who are low versus high in interest. So we have our again, we have our univariate tests right now. Given what we saw above, there wouldn't be a need to look at an omnibus level because we only had two levels of the interest variable to begin with. But as you can see right here, all of these effects are statistically significant. There's a p-value there, but again, that effect is going to be the same up here. Here, the same effect for that comparison, and then for that last comparison down here. So all those are the same. So there's not really much point in looking at the univariate ANOVA results. We scroll down a little bit further, you can see that we have a table containing Tukey's Posthoc test. So if we wanted to look just at mean differences on achievement by instructional method, and we're not really focusing in on the question of the interaction itself, you can see right here that we have the mean differences provided in this column, and we have significance levels right here. I will tell you this, that one thing that to kind of point out is that the mean differences in this column appear to be reflecting differences in the means that were coming from that descriptive statistics table that we started out with when we were interpreting our output. So if that's kind of uncomfortable, given our emphasis on the marginal means, there is another way to get comparisons without using Tukey's. Basically, what that would entail is going under estimated marginal means. Let me just kind of show you again. And under this, and you can see it kind of reset on its own right there. And while you're selecting this one right here, you could also select compare main effects. And then that would get you basically pairwise comparisons involving those marginal means. So that's just kind of an FYI for you. We'll scroll down a little bit further, and you can see our profile plot. So right here we have method A, method B, method C. So the height of the bars is associated with a given mean for those instructional methods. These are the marginal means. And then and because we had selected confidence intervals in this case, these would be the 95% confidence intervals, those error bars that you see right there. When we scroll down, you can see for interest, we have our marginal means for that. And then you can see right here we have our marginal means really reflecting each of these cell means. So as you're looking at this also kind of gives us a visualization of the interaction. So you can see right here, like for method A, you can see that here's our interest kind of a little legend right here. You can see that the kind of a reddish bar or a crimson bar is reflecting high interest group. The blue bar is reflecting the low interest group. So you can see, for instance, in method A, the bar for the high interest group is higher than that for the low interest group. So there's a considerable difference between individuals in the low versus high groups right here. In method B, right here, you can see kind of a reversal where individuals in the low interest category or group, they actually had a little bit higher interest or higher level of achievement than those in the high interest group. Not much of a difference there, but you can see that difference there is different from what we saw with method A. And then you can see for method C, we've got much more of a difference between those individuals in the low interest group and those interests in the high interest group. So you can see a much greater difference in means between method B and method C as a result. If you wanted to, you could also get those line graphs that I was telling you about. If I go back in and we'll click on plots just to kind of allow you to visualize it. I'll click on line chart right here and click on OK and OK just to generate that output. And I'll kind of scroll down, and here it is. So this is just kind of that plot. So the expectation with our line plot would be that if there's no interaction, that the lines that are connecting the means, between these adjacent categories on our method variable, we would expect those lines to be fairly parallel. We would expect if there actually is no difference in the effect of instructional method on achievement by interest, then the expectation is that we would have parallel lines reflecting the effect of method on achievement, and so by level of interest. So we would expect parallel lines, but because these lines are not parallel and because they're kind of crossing over in this particular case, that would also signal an interaction that's taking place. So that pretty much is going to wrap up this video presentation on Factorial ANOVA using SPSS. And thanks for watching.